Hi guys, I'm still home with a sick kid, so I thought I would go over some ideal gas law problems with you because they will be on the test. I'm planning on the test for Thursday now, and I'm planning on being here tomorrow so that we can go over any questions that you have about the test, okay? So here we go. Alright, this is the first problem on your flip notebook, so you should have your flip notebooks out. And let's see, it says that an underground cavern contains 2.24 times 10 to the 6 liters of methane gas at a pressure of 1.50 times 10 to the third kPa and a temperature of 315 K. How many kilograms of methane does the cavern contain? Now, the difference between this and the other laws that we've done is it brings into play an amount of gas. And the amount is used, the way that we illustrate the amount in the equation is with the letter N, okay? So, just like with all of your other problems that you did, we are going to write out P equals V equals N equals R equals and T equals, okay? All right, so our P in this, our pressure is 1.50 times 10 to the third kPa, okay? Our V, our volume, right here, is 2.24 times 10 to the 6th liters. Our N would be our amount of gas. Kilograms is an amount, okay? We don't know what our N is. They're asking us what our N is. Our R is a gas constant, and there are lots of different variables for the gas constant, but the one that we are going to use is the one that's in the little bullet points on your flip chart. That's 8.31 liters times kPas over moles Kelvin, okay? And our temperature for this one is 315 Kelvin. Now when you do this, you have to make sure that all of your units for your pressure, your volume, your amount, and your temperature work out to fit what your units are here, okay? So let's just go down the lines. For pressure, we have kPas, so that's good, because I see kPas here. For volume, we have liters, that's good, because I see liters here. For amount, this tells me that my amount is going to come out in moles, because that's what's there. And for temperature, I have kelvins, and I see kelvins there. So now I'm just plugging into the equation, and the equation is this, PV equals nRT. But we're solving for N, so we're going to rearrange that to be N equals PV over RT. And then, just like we did with all of our other laws, we're just going to plug in. So we would have 1.50 times 10 to the third kPa. That's our pressure, times our volume, which was 2.24 times 10 to the 6th liters, divided by our R value, which was 8.31 liters kPas over moles times kelvins, times our temperature, which is 315 K. Now, look what happens to all of our units when we do this. Our kPas, our kPas cancel, our liters cancel, our kelvins Okay, so what I was saying, but the video stopped, was that our liters cancel and our kelvins cancel, and we're left with moles, okay? And our answer turns out to be this crazy number that looks like this in your calculator. 1,2,8,3,5,9,4 moles of CH4. Well, note that, and that's equal to N. But what they want us to find is kilograms. So before we can get to kilograms, we know that we can use moles to convert to grams. So that's what we're going to do first. And we're going to take that crazy number, but we're not going to make it that crazy. We're going to make it 1.28 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6th moles of methane. And we need to get that to grams of methane. You guys all know how to do that. You add up the mass of methane, which is 16.05 grams. That comes from the periodic table. And we can put that over 1 mole of methane. Okay? Our moles cancel. This is 2.0601684 grams of methane. Do we want grams? No, we want kilograms. So we still need to do another problem, because we know that for every 1 kilogram, there's 1,000 grams. Okay? Our grams cancel, and our final answer ends up being 2.06 times 10 to the 4th kilograms of CH4. Now, that's a pretty crazy answer. Typically, you're not going to be asked to go to kilograms, and I'm not sure why we decided to go all the way to kilograms on this one. So let's go on to the next problem and see what's just a smidge more typical. Okay? There's a little less work involved, so I know that you guys will be happy about that. If I can move down a slide. Hold on. Come on, little cursor guy. Okay. This one says, what pressure is exerted by 0.450 moles of gas at 25 degrees Celsius in a 0.650 liter container? So if I write out my P, V, N, R, T. Okay, first they give me, it says what pressure, so I know that that's my question mark, and is exerted by 0.450 moles. That's good. By the way, if they had given me grams, I would have had to convert to moles there. And a temperature of 25 degrees Celsius in a 0.650 liter container. And then again, we know that our R value is 8.31 liters kPas over moles kelvins. So now as I look at all of this, I can say, okay, this is in moles, that's good, that's in liters, that's good, but this is in Celsius, so we need to add 273 to get it to Kelvin, which would make it 298 K. Now we can plug everything in to our PIBNERT. That's what I like to call it, PIBNERT. This time we are solving for our volume. So if we divide by P on both sides, we get V equals nRT over P. Okay? So plugging in, Okay, so now we need to plug in, and when we plug in, we know that our N is 0.450 moles. Our R is 8.31 liters kPAs over moles kelvins. Our T is 298 K over our pressure, over our, oops, you know what? We were supposed to solve for volume. So we need to fix this. We would have divided by V instead. PV equals nRT. So we divide by V on both sides and solve for P. Okay? My mistake. Okay. So now we plug in our volume, which is 0.650 liters. Okay? All right. So now when you do your math, your moles cancel, your liters cancel, your kelvins cancel, and you're left with kPAs, which is perfect because it is an example of a pressure, and P comes out to 1.7 times 10 to the third kPa. Okay? All right. Next one. Okay, this is on your practice problems. So Mr. Hondorp or whoever's subbing for me today is going to pause the video so that he can give you your practice problems. Okay, this is practice problem 1. And here we go. It says, what volume would be occupied by 100 grams of oxygen gas at a pressure of 1.5 atmosphere and a temperature of 25 degrees Celsius? So here's our P, V, N, R, T. Our volume, what volume, that's our question mark, would be occupied by 100 grams of oxygen, that's our amount, 100 grams of O2, at a pressure of 1.50 atmospheres and a temperature of 25 degrees Celsius. Our R we know is our 8.31 liters kPAs mole kelvins. Okay, so this tells us that we're going to solve for volume, but before we get started, I notice a couple of things. I notice that this is in grams, and I notice that this is in Celsius. So I need to fix those. I need to convert my grams, my 100 grams of oxygen, to moles. So 1 mole of O2 is equal to 32.0 grams of O2 because I added up 2 oxygen molecules from the periodic table. Okay? And I know that I need to change this to kelvins. Okay, so now I have solved for my moles of oxygen right here. Oops, I'm on erase. And also my 298 kelvins. And I'm looking at this and I'm thinking, oh, hold on, kPAs, and this is an atmosphere, so I need to do a conversion there also. Over on the board to the left, we have a conversions, and we know that for 1 atmosphere, we have 1 1.3 kPa. So we need to plug that in. And we get, let's see, 1.5 times 101.3 equals 151.95 kPa. Now, let's see if I can actually solve for the correct units this time. And we need volume, that's what we're missing. So, PV equals nRT. We want to solve for volume, so we divide by P, right? So now our N is 3.125 moles of O2. Our R is 8.31 liters kPas over moles kelvins. Our temperature is 298 K. And our pressure is 151.95 kPa. And I gotta tell you guys that this is the second time of me recording this part of this because I got all the way to this point before and realized that I had not converted the atmospheres to kPas. So you will do something like that, and the only reason I noticed that I hadn't done it is because when I went to cancel out my units, I went, okay, my moles, whoops, I lost my pen. My moles cancel, my kelvins cancel, and I came down here and I said, uh-oh, my atmospheres don't cancel. So I stopped. But now, because I converted it, my kPas cancel. That's why it's important to still write out your units and cancel them out so that you can see what actually is happening. And so let's solve for this. Okay, I get 50, okay, come on, little guy. All right, come on. 50.93 liters, okay? And if we want to look at significant digits, because we use this, we don't have to count these two. We can count it as 3. So 3 and 3, so we really need 3 significant digits, so we would say 50.9 liters. Now, is that what they asked it for, asked for it in? They didn't even ask for it, so we're going to leave it in liters, okay? All right, so now you guys are going to finish up the 14.3 practice problems. When you're done with the 14.3 practice problems, there is another part of the review that you're going to get. It's actually the same review for the most part, but then there are a few problems that were added onto that review, so obviously you don't have to redo the problems that you have done, but now you should be able to do that number 17 that you didn't do. And I believe, yeah, starting with number 5 in the fill in the blank part on down through the chart, you should finish up, okay? And I will hopefully see you tomorrow.